Hey, this is Rich Hopkins from the Hillendale Private Press and Typefoundry. I'm here today to try to show you how this wonderful monotype composition caster goes about establishing the set width of characters. Why is that important? Well, if you got a line of 40 characters and each character is off of a quarter of a point, then what? It's 5 points wrong as far as the width of the line is concerned? We can't put up with that. This machine operates down to tolerances of less than half a 10,000th. It has to do that consistently. And it does do that consistently. Fact is, I've run this machine for close to 50 years. And until this year, 2021, I've never had trouble with consistent set widths. In the process of learning what was wrong with this machine and fixing it this time, I've learned a whole lot about it that I didn't know before. And the purpose of this video is to share that information with you. It's not well covered in the manuals, either by the English company or the American company. And so we'll get into it right away. The monotype composition caster. This particular machine was invented around 1910. Can you believe that? Before we get too far along, I want to make sure everyone's on the same page with regard to what we're talking about when we mention set width. This is an example of a typecast character. We're talking about the width of the cast character, which goes from here to here, not necessarily the character itself, because often the characters have a little bit of white space built into them. And so I'm talking about maintaining this dimension right here, the set width. On the monotype, the set width is not tied to the matrix, it's tied to the way the mold is set. And therefore you can have weird things like this thing right here. I'll try to get it to you. There's a piece of type, 24-point body, but if the character actually is cast is a 36-point character. And so it's hanging over the body on all four sides. Now that's an extreme which you'll virtually never touch, but that gives you an idea of the flexibility of the monotype. It is capable of casting a character wider than the body that it's on, or narrower than the body that it's on. So we're talking about that width. That's the set width of the character. Just for comparison purposes, this is the Thompson casting machine. This is the way you change the adjustment as far as set width is concerned by turning these screws in and out. And this space right here is where the width of the character is established. And so when the body piece comes over here and closes up right there, steel against steel, there's no chance for variation other than the fact that as heat gets built up in the machine, it expands a little bit and therefore the set might change a little bit. And if it gets cold, the opposite is true. The tightness of this setting is pretty much directly mechanical too. You can mess it up a little bit, but the bottom line is that every time the machine cycles, that's how set width is established. Of course, when you're running the Thompson, you cast everything to the set width that you have it set at. You change the set width, you change the matrix, and you go to the next character. Comparing that to the composition caster, which changes the set width of the character every time it cycles. We'll get into that now. Right now the machine is completely assembled and I can't do very well to show you what's going on, so I'm going to take the bridge off so we can look at the mold, which is down there in the middle, and see what's going on here. Now we're looking down on the mold, which of course is right here. This is the top of the mold, and this is the opening where the matrix settles down to create the letter, and of course the body is a part of the bottom of the mold. This thing right here, which goes through right like that, is the mold blade. And as the machine cycles, It closes and pushes the type out into the type carrier, and then it sets itself up for casting the next character, and it opens back up. You can see the mold blade, or the mold blade opening up. I would say that it's casting something like an M quad right now as far as width is concerned. Okay, that entire mechanism, the mold blade, is connected with this little pin, and I just disconnected it, but I'll put it back in. And that mechanism goes on back here, and everything in that direction is additional paraphernalia for operating the mold blade. Ultimately, the mold blade is controlled by a setting which is established with a pin wrench by turning this item right here, going click, 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 click. There's a little detents all the way around, and there's a spring that comes up underneath that engages those things. If the spring gets weak or broken, that it would be free to move, and if it moves, it changes immediately. It changes the set width of the character. I had trouble with this a couple times ago, and so I'm using this as my first step in finding out what's wrong with my machine now, because the set width right now is all over the place, and it might be because this is free to move as the machine operates. You can see how definitive the stick click is, and in my mind I don't think it's a problem, but I'm going to take it apart and check, see what it is anyway. In order to do that, I have to take all this mechanism apart, and so that's the next step. Now we're looking at things a little bit more closely. This is a mold blade. By the way, the mold is still on the casting machine, and when the mold blade opens up and closes like that, that's what controls the width of the character when it's being cast. So the back side of the mold blade is perfectly flat, and it comes up against this pin right here. This pin is the other side of this little clicker. That's what I call it, a clicker. By the way, nothing that we're talking about right now is covered in any monotype manual. Apparently they decided that the adjustment would be made when the machine was manufactured, and it would never need to be changed, and so why talk about it? I had to take this part out and inspect it closer. Looking at the part now, it's the best time in the world to do preventive maintenance. That compound spring that I was telling you about, I had it out just a little bit ago. As a matter of fact, here it is. It's sticking down like this. It seemed to be working all right, but here's the spare that I have, and that shows how the compound spring really is supposed to look. It's sticking out here on the back, and then back there. There's a pin right here, goes all the way through the body. You push that pin out, you can take the spring out and put a new one in. And never will I have a better opportunity to make that fix than right now. And so I'm going to take it apart and put the new spring in to find out what's wrong with this one. Here's a spring that I got out of it. This is a new one. And this is I don't know exactly how it got bent like that. I have no idea. But very obviously I should replace the spring. And since I have the spare, why not? I have turned it down now far enough so that I can get the end of the spring into the end of the piece right here. And now I need to get the spring positioned properly. This is a pin that goes through the body that holds it, and there's a loop in the spring right now, right there, which I need to move it just a little bit more that way. And now it has a very clear click to it that it did not have previously with the busted spring that was in there. Tools and more parts and more parts and more parts and more parts. Reassembling this thing is going to be a lot of fun. Well, folks, now that you've heard everything about the clicker and how it comes up against the end of the mold blade and operates the machine and all that, I have to admit that that's not what the problem was. But where else are you going to find about that little compound spring and all that kind of stuff? Someday you'll need that information. But now we have to go somewhere else to look for my problem. And right underneath this shield, a bunch of wedges. And underneath the mechanism over here are some rods and stuff that we really have to study closely. And the only way you can see what's going on is for me to take the machine completely apart. I'm not going to show the video of taking it apart, but I am going to show you once it's apart, because then you can see very clearly what the wedges are, and maybe you'll better understand what they do. This illustration is from the English Composition Caster Manual, and it shows the wedges in the machine. Shown in blue is a normal wedge, which changes with each typeface and each size. Next are the two justifying wedges. These two wedges stay in the machine all the time, and they establish the width of all spacing. This is a space transfer wedge. It enables calibration of the wedges that are already in the machine. And this is a type transfer wedge, which enables calibration of the machine when the normal wedges are changed in. Now shown in dark green is a type transfer rod. And underneath the green space transfer rod is the type transfer rod, which is shown in sort of a gold color. And also vertically in light green is a micrometer wedge, and that enables very minute adjustment of spacing widths. First is a space wedge, and that's what this looks like. That's the underside of it, and the connection is an oval hole right there. And it connects right there to the end of the rod, and then it slides in. It should be very free, nothing interfering. Right now I've got it loose on the other end so that I can move it in and out and make sure it's not being fouled. And on top of the space wedge, or the type wedge, which is this one, is a space wedge. And the space wedge looks like this, and has a connection there, and this is a fine adjustment. It goes down on top of the other one and hooks in. Oop, I had it upside down. It goes in this way with the groove on top, goes into the latch and hooks right there. It's fixed right now because either one or the other moves, but they both can't move together. So that's the way it goes together. That is not discussed in the manual. It's good to know how it's supposed to go together. I've already shown you the normal wedge, which is already in here. I've taken everything out of the machine trying to get it to work properly. And these are the coarse and fine wedges for establishing the width of justifying spaces. I have them out of the machine, and I need to put them back in. I don't know whether you can see the marking or not, but it says 11D on one of them and 10D on the other. 11D needs to go to the back of the machine, and 10D needs to go to the front of the machine. There it is. This big block of steel goes at the left-hand end of these wedges to keep them from going too far to the left. But it has to be out of the machine in order to put the wedges in and out. So I'll go to the back and see if I can't get these wedges in there. I've got the wedge in my hand and moving it in. There's not a whole lot of space to do anything in there. There's a V groove in the bottom of the wedge right here, and the lifter goes into that groove and it raises it up off the teeth, and that's what enables it to move back and forth. And I'm in the process of getting the back wedge into the machine, and hopefully I'll get it in there. It's cooperating a little bit. It's coming in. I don't know whether you can see it over here or not, but there's the end of it. And now I'm going to, this is a lifter. This is what lifts it right there. And apparently it's in a proper position. Otherwise it wouldn't lift, right? This tool right here, which is used for setting the set width on the orphan ante, with this hole on the end, fits right on the end of those two justifying wedges. And that might enable me to move the thing a little bit more easily than trying to use my fingers and hook it. And now maybe I can, there we go, it's moving a little bit better. So I'm going to move it and get the wedge that way. So I'm looking right down on top of it now, and I've got the two wedges in there. And you notice this no longer can come out because it goes against the wedge. So everything is held in nicely. Down in the machine, and see if I can show you the wedges. There they are, 10D and 11D. If they're in the machine, I'll take this hook and grab the end of one of them. And you notice it doesn't move. But if I lift up on the lifting rod here, the lifting rod is this thing right here. You can see the wedge moving up and down on that one, and same on this one, the other one. You never get to see a machine apart like this, so I'm going to take it aside to explain things, how they work. Here are the air pins, which are controlled by the paper tower, and they come up, and these two things here close in on the pin that's raised up. Okay, you notice that the pin, this is a pretty fragile thing, the air pins, and therefore the position in the mat cases is a very strong spring and all that kind of stuff. And so Lanston didn't want to put all that pressure, that spring, on the air pins. And so when they come together on the air pin now, at the same time they're positioning, when these things position it, see this tip that's sticking up right here? This part right here is what's really important, because it pulls together on that and positions it. And then it locks into place as the machine turns. It locks into place. And now at that stage, these are free to go back for the next character to be cast. But this right now is absolutely locked. And I do have that part. Here is the part, which is down in there. And this is a locking pin, and it goes together and locks it like that. And that locking has taken place in this caster right now. It's right there, it's locked. It would not move. You could take a sledgehammer and beat on that and not make it move. This is the American one. The English one, these detents are a lot narrower, and there's only one finger instead of two fingers locking. And so in many ways, the American system, why they changed it, I don't know, but the American system is a little more positive than the English system. But at any rate, it's locked in position. Now, I think we can see, looking down now, that I've cleared out a whole lot of parts in here, and we can now see the wedges. Here are the coarse and fine space transfer wedges, trace wedges. Here are the two rods. They're in the machine, one on top of the other, and they do move while they're in locked position right now. And of course, the normal wedge, which in this case is a normal wedge, this particular normal wedge, it goes in there. It's very easy to see where it goes with all the parts off of it, and it runs into something. And I have to move that forward to get it clear. There we go. Now the normal wedge is in position, and it's locked down. And so you can see, I hope, the normal, I can get my finger in there, the normal wedge is right there. The two rods that control The positioning for the width of the character are right here, and these wedges right here, the fine and coarse wedges are in the back. And by the way, the 10D is in the front and the 11D is in the back. You can get them out, and you could get them switched around, which would mean, of course, that your calibration will be exactly opposite of what it should be. But anyway, you can see everything that's in there. This is generally all covered up and you can't see anything. And so that's the main reason I decided to do this video. I've never had a machine apart this far before, and now it's time to get serious about putting it back together. I am blessed with an abundance of spare parts, and therefore I'm able to show you what these things look like. The American manual refers to these as rods. They set the space transfer wedge and type transfer wedges in place. This is a rod. You notice this detent right here. That's very important. The end, this is where the screws, and the other end is important because the actual one, this is a type transfer rod, and this is a type transfer wedge right there. And you notice the oval hole, it goes together just like that. And so that's how that operates. It moves it back and forth in the machine. Same is true of the space transfer rod. This is it. And you notice it's just got a V type setting, and it goes together. This is a space transfer wedge, and it goes together that way. And so they go together quite well. And this is a micro adjustment on that. Some people say you never mess with them. Louis Mitchell from M&H told me that he had these space transfer wedges in abundance in his shop, marked for particular faces and particular wedges, and that they changed them. That's unusual. In my shop, I never change it, but occasionally I do adjust it up here. Okay. The big deal, though, is how these things go into the machine. Now, it's very easy to take them out of the machine. This is the end which is on the right-hand end of the machine, and you just absolutely pull it out after you've taken these screws off, of course. Same on the other one. And as far as the way they go into the machine, they go this way, so that detent right there is opposite each other. And so I've got them together. That's the way they go into the machine. So you just go back to the right hand of the machine, look back in there and shove them in, right? And you run into a solid wall. And that solid wall is right here. And that's what gave me almost 2 weeks worth of consternation. I knew that these things were operated by going through this thing. See that hole right there? Going through that. But somehow after I got it out, it's round, and somehow it got turned. And so I was trying to shove the rods in the machine, but I was running into the solid wall. The next question is, how do you get that thing turned around so that you can get them in? Let's explain how they go together. Okay, I'll just put the two of them in there. And you notice that I can't get both of them in. I can't get both of them in. The ingenious method they have, that detent has dropped down in, and it has to be down in order for this one to go in. In the position it's in right now, the space transfer rod would work back and forth. But if this were lifted, but when it's lifted, then this one is up and it can move back and forth. And so those things going back and forth through that, that's what it's all about. And that motion right there, which is, I've got it upside down, it's pulled up from the top. It is extremely difficult to get this turned in the right position so that you can get these rods back into the machine. Here's the machine part that I just showed you right here is down inside here. And so I needed to get into there somehow so that I could get to this and turn it around, twist it. It's operated by this center pin that goes right there, and it goes up and down with the function of the machine. And so it was in there, and it was like this position, which meant that I couldn't get those rods through it. So I needed to turn it this way. So you can see perhaps that I was taking the screws out, and I started working, trying to get this whole mechanism off. I still haven't found out how to get it off. When I put my finger back in there and felt around, and I could feel the round edge right here. I could feel it. And so I fiddled with the screwdriver until I managed to get it turned around this way. It is free moving in there, and that's what the problem is. It's, of course, kept in position by the rods going through it, but it was free moving. A real problem, because I really had to strip the machine down to the point where I could get my finger in there to find out how to turn it. And I'm going to show you, looking straight down into the machine, what we're talking about now. You never have a machine this far apart, but since it's this far apart, I'm going to get the camera down in there and show you what's going on. As I say, I spent 2 weeks trying to find a way of getting these rods back into place on the machine. They are in place now. I do want to talk about the mechanism for switching those two rods. This is a drawing showing the operation of the two rods from the American Monotype manual. The important thing is down at the bottom left-hand side. The American manual talks about making adjustments down in here. It talks about making adjustments in the spring pressure, making it equal at 65 degrees and 180 degrees, and better than half of the adjustments are almost inaccessible. I found that this short shaft connected to the inaccessible big spring under everything, this rod has 3 nuts on it which allow you to lengthen and shorten it, directly affecting the throw of the 2 rods up on the top of the machine. Here the machine is in action before I finally found the sweet spot. You will notice hesitation in the throw of the top rod. This causes the machine to miss half of the adjustment and thus causes it to cast bad type, sometimes for several lines. With much patience, I fiddled with that adjustment, shortening and lengthening the little shaft until I found the sweet spot, and thereafter the rods have been throwing with no hesitation, and the machine once again is casting perfect type.